Welcome to The Explainer. Today we're breaking down a new framework that could completely change how we build intelligent AI agents. It's called DreamGym, and it's all about teaching AI inside a synthetic dream. So how does it all work? Let's get into it.
It's a huge question, right? And for many of the most powerful AIs out there, the answer is a process called reinforcement learning. You can just think of it as learning by doing. Trial and error with rewards when you get something right. But when you try to do this in the real world, this simple idea hits a very complicated and very expensive problem. Because that whole learning by doing thing, well, in the real world, it's hit a massive wall. And this isn't a small hurdle. This wall is built out of some really serious fundamental challenges that have slowed progress down to a crawl. So traditionally, AI agents have to learn from direct, real-world interactions. The problem is that data is scarce, it's super costly, and frankly, it's pretty unreliable. But this new paradigm, experience synthesis, it just flips this whole thing on its head. It asks a brilliant question. What if instead of collecting experience, we could just generate it? Suddenly, your training data becomes abundant, cheap, and perfectly adaptable. And here's the real crux of the problem. Gathering enough good data is just incredibly expensive and slow. The tasks you can find often aren't diverse enough, the feedback the AI gets is spotty and unreliable, and the infrastructure you need to run it all is a total nightmare to manage. Oh, and sometimes it's just flat out dangerous. You can't let an AI learn a lesson by, say, accidentally deleting a real user's files. So, how in the world do we get past this wall? Well, researchers have proposed a really fascinating solution called DreamGym. The core idea is actually simple, but it is so powerful. Look, instead of letting a student pilot crash a bunch of expensive, real airplanes, you have them practice for thousands of hours in an ultra-realistic flight simulator. They learn safely, they learn cheaply, and they can face scenarios that would be totally impossible to replicate in real life. DreamGym does exactly that, but for an AI agent. So if you want the formal definition, it's a system that's designed to generate a basically endless stream of high-quality training data. It's almost like a custom-built dream world where the AI can practice any task over and over and over again until it gets it right, all without ever touching the real world. And this brings us to a really key insight from the research. The simulation doesn't have to be a perfect pixel-for-pixel clone of reality. It just needs to be causally grounded, which is a fancy way of saying it just has to be good enough to teach the right lessons about cause and effect. That right there is the secret sauce. So let's pop the hood and take a look inside this thing. What are the core components that make this AI dream world so effective at teaching? It really boils down to three brilliant parts. First, there's a reasoning experience model. This acts as the physics engine of the dream, making sure that if an agent does something, the outcome actually makes logical sense. Second, an experience replay buffer is the world's memory, keeping the simulation grounded in reality. And third, you've got a curriculum task generator, which is basically a personal trainer, constantly creating new and harder challenges to make sure the AI is always improving.
Okay, this all sounds great in theory, but does learning in a dream actually work in practice? Well, the researchers put it to the test, and honestly, the results are pretty staggering.
First up, let's look at environments that were considered non-RL ready. Now, these are places that are so complex and messy, like the WebArena benchmark, which simulates real websites, that the old training methods just couldn't even get started. It was basically impossible to use reinforcement learning here. But with DreamGym, training suddenly became possible. And not just possible, it delivered over a 30% performance boost compared to all the other methods. For a task that was previously considered unsolvable like this, that is a massive leap forward.
All right, now for what might be the most surprising number of all. This is the amount of real-world interaction data DreamGym needed to match powerful, traditionally trained models on tasks where RL was possible, just really, really expensive.
That's right. Zero. Zilch. Nada. I mean, look at this table. In environments like WebShop, the traditional models needed 80,000 real-world interactions to hit a certain performance score. Agents trained purely in DreamGym's synthetic world, they got comparable scores without a single real-world interaction. They learned everything inside the dream. So what happens if you combine these two worlds? The researchers tested a hybrid sim-to-real approach. First, they let the AI train like crazy in the dream world, and then they woke it up and gave it just a little bit of real-world experience to fine-tune its skills. And in this method, Man, it was the best of both worlds. It consistently crushed the performance of models trained only on real data, sometimes by over 40%, all while using less than a tenth of the real-world interactions. It's like giving the AI this massive head start before it ever has to touch the expensive real environment.
Now, to prove that every single piece of this was crucial, the researchers ran what are called ablation studies. It's a fancy term, but it basically just means they started systematically unplugging things to see what would break.
And the results were crystal clear. The second they removed the dream's memory or its ability to reason logically, the quality of that synthetic experience just plummeted. The dream became inconsistent and nonsensical, which proves that every single piece of this machine is essential.
So, what's the big takeaway here? What does all of this mean for the future of AI?
Well, according to the researchers, we may have been focused on the wrong bottleneck this whole time. The problem isn't necessarily that we need better learning algorithms. It's that we need better learning data, and we just can't get that data from the real world at the scale we need.
This is a fundamental shift in how to think about this stuff. By focusing on generating high-quality learning experiences instead of just trying to perfectly mimic reality, we can make AI training dramatically more scalable, way more efficient, and ultimately a whole lot more powerful.
And this leaves us with a pretty provocative thought. We are just seeing the very beginning of what's possible with synthetic training data. And it raises this fascinating question for the future. If an AI can get this smart, this fast, while it's dreaming, what on earth will it be capable of when it finally wakes up?